Hello, ladies and gentlemen. Once again, coming to you not quite live from One Take Studios, where today's topic is percentiles and box and whisker plots. This, I think, is some kind of interesting stuff, and I hope you find it interesting as well. So let us ponder percentiles to begin with here. First, please understand that a percentile is not the same thing as a percent. I will demonstrate. The pth percentile, yes, capital P is a variable, the pth percentile is a value such that p% of the data fall at or below it. What does this mean? All right, percentiles. You've probably taken a standardized test at some point in time in your life, and maybe you got a score that says that you reached the 95th percentile on your standardized test. What does that mean? I have bad news for you. That does not mean that you got 95% of the test, because that would indicate that on the test, out of every 100 questions or so, you got 95 of them right. You picked up that many points. 95th percentile is not that. This says instead that out of everybody that took this test, 95% of the data falls at or below 95%. That means out of all the people that took this test, you, if we're putting this in rough words, you managed to score you know what? I'm going to make this even better. You managed to outscore, there we go. You managed to outscore 95% of the people who took the test. Now, normally we say that's a really good score. And you know what? I would probably say that under most circumstances that is. That means that out of all the scores that are out there, so out of every 100 people that took the test, you actually scored the same or higher than 95% of them. That does mean that 5% of people outscored you, but again, that's not bad. I do think this is fascinating though, okay? So, 95th percentile. You managed to outscore or score as much or more than 95% of the people that took the test. What if, just ponder life for a second, what if everybody who took the test did really, really badly? What if you have a group of completely normal high schoolers and all of a sudden you're taking a test about nuclear physics and you scored the 95th percentile? Does that mean that you're a brilliant nuclear physicist? Probably not. That means that out of all the people that scored poorly, you scored better than 95% of them that scored poorly. This doesn't actually tell you your amount of knowledge collection. This just compares you to other people that have done the same. So a percentile does not give you a percent. It does not tell you what you know or do not know. It simply compares you to other people, other scores, which I think is fascinating. On the other end of that spectrum, let's say that you scored in the 60th percentile. Normally we would say that's bad because there's 40% of people then that scored more than you if you're only at the 60th percentile. Well, yes, but what if you're in a room of completely brilliant people and you're taking tests about the alphabet? That just means that 40% of them outscored you, but you might all be brilliant. You might all have, really, really high scores. But again, this number is just a comparison to other people and other things and other numbers that are out there. So I hope that made some sense, because I think it made some sense. I don't know. I like it. I think it's interesting, and I think that we use this to compare ourselves to other countries, to other states, to other students. Why don't we just use percents? I would rather know how much I know rather than know how much better or worse I am than other people. I don't need to compete against other people. I want to compete against myself. Tell me what I understand or don't understand, and let me work on that. But that's just me. So, in the world of percentiles, we then have things that are called quartiles. And quartile, the idea is I'm going to take my data and split it up into did you guess it? 4 pieces. So there are 4 quartiles. And so quartile 1, usually we just use a Q1, and quartile 2, and quartile 3, and do we really usually have quartile 4? Because we could have quartile 4, but what would that mean? That wouldn't mean a whole lot. This would just mean all of the data. So At quartile 1, we're saying this contains the bottom 25% of the data. At quartile 2, this would be the bottom 50% of the data. Wait a minute. Now, okay, I know something that we've talked about before with measures of central tendency, where you know, like, where the data is split half and half. What is this? This value should be the same as the median. The median is quartile 2. That number that's in the middle splits your data. 50% on one side, 50% on the other. So the Q2 is just your median. And that means that Q3 would be where 75% of your data. Q4 would then just be referencing the fact that you have all of your data. Which, great, I have all of my data. Yay me. What can we do with this fun stuff? Well, a couple things actually. We can use this to create a new type of data organizer called a box and whisker plot that is sometimes called a 5-number summary. 5-number summary. Well, maybe you can guess where some of those 5 numbers might come from the 5-number summary. Let's see if we can figure it out. I'm going to take a set of numbers that I've been using a lot lately, and I'm going to attempt to put them in order here. So the numbers are 2, 3, oops, I missed 1. Yep, 1, 2, 3. The next number is 7, and then we've got a 12, a 20, a 20, a 24, and an 86. All right, this is my set of numbers right here. 1, 2, 3, 7, 12, 20, 20, 24, 86. By the way, in case you cared, this is the number of pencils that everybody in my 4th hour lunch has, or at least a sampling of everybody in my 4th hour lunch. Guess which of us has 86 pencils? Hint, it might be me. Everybody else is relatively normal. All right, so if this is my data set, and I'm looking at what are these markings, what are these quartiles, how can I segment this data? Well, where's the median? Right there. Ladies and gentlemen, 12 is the exact center of my data. I would call it the median. 12 is also quartile 2. Because I'm saying that 50% of the data is below this, 50% of the data is above this, so this is my 50% marking. So 12 is Q2. It's the 50th percentile. All right. Ooh, careful. Percentile, percentile, percentile. I know I didn't write out the word. I apologize. Please forgive me. I did say that 25% of the data is below this value. So, there you go. All right. So, where would Q1 be? If this is the middle of my data, Q1 would have to be the middle of the bottom half. So this is like the median for the bottom half of my data. So let me take the bottom half. Where's the median here? Well, 2.5. I don't have an exact middle of my bottom numbers here, so 2.5 is the middle of these two. 2.5 would be my first quartile. So I would say of this data set that 25% of my data is at or below 2.5. And I would say that 50% of my data is at or below 12. So what is Q3? Well, this is going to be, again, the top half median. So if I just focus on these pieces right here, again, I don't have an exact middle. I've got 2 data values that average in at 22. And so that is my Q3. At 22, we are saying that 75% of my data is at or below 22. All right, so if I'm using this to create a 5-number summary, I want to separate this, I think, as my example. All right, so everything below the squiggly line, this is my example. A 5-number summary. 1, 2, 3. What else might be good to include? I am betting that people might also want to know my absolute lowest value and my absolute highest value. So when we are talking box and whisker plot, a 5-number summary, we are using the min and the max, and then our quartile numbers to organize it. You will want to create this on a number line, because if you are just making up numbers and you don't have an actual number line, then you are possibly skewing your data in a way that you don't mean to. So I have to somehow count all the way up to 86. How do I want to count to 86? I think I might count by tens. That sounds good. Let's start there. So this would be, let's call this 0. 0, 10, 20, 30, 40, 50, 60, 60, 70, 80, and 90. That gets me to 86. That's actually pretty good. All right. We use our quartile numbers, which again, those are percentiles. We use our quartile numbers to make the box part of our box and whisker. So we say the low end of our box is at 2.5. Ooh, this is going to be squishy. 2.5 is going to be probably right about there. And then the high end of my box is at 22, which is right about there or so. So Q1 and Q3 create the box part of my box and whisker. Well, what do I do about the 12 then? The 12 goes as a line in the midst of our box, about where 12 would be. Now, these two pieces of my box look like they're relatively the same size. That might be true. That might not be true depending on the data set. All right, this could be very different. The other part of this then, stem and whiskers, well, this is where our max and min come into play. This is going to go all the way down as far as 1, which actually isn't that far from 2.5. So my left whisker is really short here, like my cat ran into a wall or something. Got too close to the fan, maybe? Who knows? And then the high end, 86, would be right about there. So this whisker is actually incredibly long. By the way, I have seen this done where 86, which clearly by length is going to be an outlier for this data set. Some people will just put a star at the outlier and use the next number down, the 24, as the other end of the whisker. So you could get a couple things that you could do there. This is our box and whisker plot, which uses percentiles to piece together our data. So if I look at this, I know you're saying this probably makes sense, but if I ask you right now, why is this whisker so long? What would you say? Think of an answer. Why is this whisker so long? Are you going to tell me because there's a lot of data here? I hope not. Because this represents one of my quartiles. This is saying that 25% of my data is here. So 25% of my data is between 22 and 86. So the top quarter of my data is really spread out. What is this saying? That there's not a lot of numbers here? No, this whisker is another 25% of my data. I'm saying 25% of my data is really close together here at the low end. This is another 25%. This is another 25%. So 1/4 of my data, 1/4 of my data, 1/4 of my data, 1/4 of my data. It's all based on percentages, the amount of the data, not the actual values. But we can see then how much they are spread out. Bonus question, just for the fun of it. What would you say is the mean? If you're looking at all this, where would you say the mean is? Think about that. Ponder life. I'm going to show you two things. One, there's something that is called an interquartile range. Interquartile range. And that is simple enough. It's a range, but we're just saying this is our distance from Q3 to Q1. So in this case, my Q3 was 22, my Q1 was 22.5. So for this particular data set, it has an interquartile range of, let's see, 22 minus 2.5 is 19.5. So this set has an interquartile range of 19.5. We're saying that half of our data, the center-ish half of our data, is right around a range of 19.5 for the spread. Okay, so the other thing I want to show you is this. Going over, switching screens because I can. Yes, there we go. All right, so these are the same numbers. They're not in order, but these are the same numbers I typed in before. So this is my data set, which is 1, 2, 3, 7, 12, 20, 20, 24, and 86. I put them in my spreadsheet, and now I'm going to ask the spreadsheet to do some calculations. Where is everything fun and exciting? In the menu, of course. So we are working with statistics. We would like to do some calculations. Oops, I hit linear regression. Escape, escape. I don't want to do a regression. Got too excited there, sorry. Statistics. And then stat calculations. And then one variable stats. Again, we have one list of numbers. We don't have ordered pairs here. We have one list. There we go. Everything's in column A, the first column of my spreadsheet. Run it all. Okay, so this gives us all kinds of stuff. This gives me, what did you guess the mean was? The mean of that set was 19.44. So how well did you do? That's not bad. This gives us, ooh, S. That is the, can I use this? I can, there we go. That is my standard deviation versus my population. Again, the difference between these two, this is smaller because I know it's the entire population. The sample standard deviation, which is this guy, is slightly larger because it's a sample and we don't know if there's all the values there or not. So for this set, I did take a sample of my lunch hour, so this would actually be the more appropriate standard deviation. Which again, because it's such a large number, means my numbers are really spread out. And again, it's that 86. It's the 86's fault. Wait a minute, what are these? The minimum value is 1. Q1, I bet you that's quartile because we just used 2.5, and sure enough, there it is. The median, otherwise known as Q2, that was 12. There's, guys, if we run the one number summary, we get a whole bunch of measures of central tendency, we get a whole bunch of measures of variance, but we also get our 5-number summary. Look at, there's all of them. All of them. Right there, ready to go. So I can use my paper and I can stretch everything out. Where'd it go? This one back again. And I can find it this way. But if I'm nice to my calculator and I ask, it'll also give me the 5-number summary to make my box and whisker. Again, box and whisker, please make sure that you are using a number line to line it up. Otherwise, you're just making stuff up, which can be very misleading. And do I have anything else I want to say to you today? You know what? I don't think so. All right. So have fun. May you always be in the 90th percentile of life. I don't know. That could catch on as a saying. All right. Thanks, guys.